You know that feeling, right? You're staring at this wall of super technical text, trying to figure out how some system works. It's dense, it's confusing, and honestly, it's a little bit boring. But what if you could just bring it to life? Well, today, we're diving into an AI that does exactly that. It transforms these complex descriptions into dynamic, animated diagrams. And we're even going to go behind the scenes to see how its creator squashed a really critical bug. So let's look at a classic problem. How do you explain a system with just text? You've seen stuff like this a million times. A user sends a query, it hits a server, goes to a database, and then a response comes back. I mean, you get it, you can follow the logic, but it's totally static. You don't really feel the journey the data is taking. This is the issue right here. Text gives you the facts, but it doesn't always give you that intuitive click. Okay, but now, what if you could feed that exact same text to an AI and get back a fully animated diagram? One where you can literally watch the data move from one component to the next. All of a sudden, the entire process just makes sense. That's the magic we're talking about today, an AI that creates that aha moment of understanding, all through visualization. So here's our game plan. We're going to start with the main idea. Then we'll peek at the AI's instruction manual. After that, we'll see it build a pretty complex medical workflow. Then comes the fun part. We'll follow the story of a tricky bug and its really clever fix. And finally, we'll wrap up by talking about why this all matters for making AI easier to understand for everyone. All right, first up, let's talk about the big challenge this AI was built to solve. It's all about bridging that huge gap between a technical description on a page and a real intuitive grasp of how a system actually works. And here's the tool that makes it happen, Flow Gen AI. Its job is simple, but it's incredibly powerful. You give it a text description of pretty much any system architecture, and it automatically spits out a clean, professional, and, this is the key part, animated diagram. It's basically visualization on demand. So how in the world does this thing actually work? You might think it's all about some crazy, complex AI model, but the real secret sauce? It's in the instructions. It's all about the master prompt that tells the AI exactly what to do. And this isn't just some vague request, you know? It's a super detailed blueprint. The prompt tells the AI how to draw the boxes, how to make the data flow along the arrows, what shapes to use for things like decision points, and even what the final design should look like, clean and minimal. That level of detail is absolutely crucial for getting a great result every time. The prompt even gets down to the nitty-gritty of color coding, which is just brilliant for clarity. By giving specific colors to different actions, like blue for input, purple for AI processing, yellow for a decision, the final animation becomes so easy to read. You don't have to guess what's happening. The colors tell the story for you. Okay, theory is great, but seeing is believing, right? Let's dive into a real-world example. We're going to watch how this AI takes a pretty complex medical workflow and turns it into a clear visual story, all based on that master prompt we just talked about. So it all starts right here. A patient, or a user, submits a query with their symptoms. The AI visualizes this as a little package of data that starts its journey, moving to two places at once. One path goes to retrieve the patient's health records, and the other goes to the main processing server. And this is where the AI's brain really kicks in. The system has a similarity search engine that compares the user's symptoms to a huge database of known diseases. In the diagram, this is represented by a diamond shape, a classic decision node. The entire flow now depends on the answer to one simple question: did we find a match? And here's where the path splits. If a similarity is found, the system summarizes the findings and updates the patient's medical records. But if not, it automatically sends a notification to a doctor for a human to take a look. No matter which path it takes, the process comes back together to send a final, helpful response back to the user. So it seems like the system works perfectly, right? Well, almost. Like with any big project, there was a problem. A single, really frustrating bug in the animation was basically ruining the whole experience, creating this weird, confusing loop. So here's exactly what was happening. That little animated box, our data packet, would finish the first step and was supposed to move to the second one, but instead it would just instantly snap right back to the very beginning and start all over. And it would do it again and again. The logic was right, but the animation itself was completely stuck. So what was the problem? Well, the animation was focused on the nodes, the boxes. When the token arrived at a node, it would get, well, confused, and just snap back to the default starting point. The fix was so elegant. Instead of telling it to go from node to node, the developer told it to lock its movement to the path, the arrow connecting the 2 points. A simple change in perspective. And here's the clever bit of math that made it all work. This formula is for something called linear interpolation. But in simple terms, all it does is tell the animated dot to constantly calculate its position based on how far it's traveled along the line between the start and end points. So instead of just knowing start and end, it knows every single point in between. And that's what creates a perfectly smooth journey. So to put this fix into action, the developer wrote a new, super specific debugging prompt. It told the AI, hey, lock that token to the edge path, period. That stopped the snapback problem cold. It also stopped the diagram from redrawing itself mid-animation, and it made it crystal clear that the only time a loop was allowed was at the very end of the process, where it was supposed to be. Problem solved.
So we've seen how the AI works. We've even seen how a tricky bug got fixed. But this whole story connects to a much bigger idea. What this project really shows us is the huge impact of making these complex AI systems understandable to everybody.
So why does all this matter? Because it makes AI explainable. Think about it. If you're a patient, seeing a clear animation of how your symptoms are being analyzed is way more reassuring than just being told the algorithm is on it. This is how you build trust. This is how you make these abstract processes totally transparent. It proves that we can build AI even in really important fields like healthcare that isn't just powerful, but is also deeply intuitive.
And that brings us to a really fascinating final thought. We just watched this AI animate a medical workflow, but the potential here is so much bigger, right? Imagine animating economic models or complex supply chains, or even how ideas spread online. The big takeaway is this: if we can clearly describe a process in words, we might soon be able to just watch it unfold. So what complex idea would you want to see brought to life?